Okay, for this session, short session on the concept of middleware, and particularly middleware as it goes in the JSON stack, and implementation-wise, how Express does it. Before we get to what happens in code, I kind of need to talk conceptually about what middleware even is, because again, it's one of these polymorphic terms. It's a term that's kind of changed its meaning when you get in the context of Node.js and the Express stack. So what do I mean by that? Traditional view, in a traditional view of enterprise, and the enterprise class system, if you will, that view of middleware relates to a distributed component based or distributed services based type of enterprise system. In there, you have these different tiers. We talked about tiers last time. And so you may have, a client tier, some server tier, and some shared tier in between there. You have an assumed layered architectural style, right? Layer 1, layer 2, layer 3, if you will. And one or more layers sits between the clients and the servers. Now, when we talked about client server last time, I mentioned the browser tier and then three tiers above. If you remember, I did a four-tier example. In this particular diagram, though, the client is actually on. This is strange. The client is on the server. What do I mean by that? When you look, and I'm going to switch again. I'm going to go back to this diagram in a minute. But when you look, I drew for you a diagram that looked like this: browsers, right, that we're talking over the internet to web servers, the web server tier here, and then these talk to application servers, right? So what I'm talking about is these application servers. This is code, so when it says Tomcat in here, this would be a Tomcat, or for this class, this would be a Node.js process that's running, all right? Or we may actually run the Node.js together combined here. Tomcat can do the same thing. But either way, again, thinking of your web application as an adapter, what happens is this: when you have to call code in here, it may have to go off and use services available in your enterprise. I'm going to draw a bounding box here, and those services included things like a mail server. They included things like one or more databases. They could include an ERP system. This could be your HR system. This could be your whatever. It also could be external systems, right, that you talk over an API in a B2B scenario, right? So you're executing a transaction with PayPal, let's say, an e-commerce scenario. This whole part back there and the layer that sits between this and your business, remember the model and the business logic that went with it and so forth. All right. Structurally, this is called to facilitate this communication in here. You have a middleware layer. That middleware layer coordinates the interaction with all these services, all right, and all these or components or what have you. Examples of middleware include messaging systems, or what's called MOM for, I didn't scribbled that M. Let me fix that. MOM, it stands for it's an acronym, stands for Messaging Oriented Middleware. You may have a distributed transaction service. So maybe you're trying to do what you know is a database transaction, but across many of these, right? You have multiple databases, so you have to coordinate a transaction between them. It could be an entire what's called ESB, another acronym, Enterprise Service Bus, to coordinate between distributed services. So you could do some business process long running transactions with technologies like BPEL and the like. So again, like I said last time, it's not the intent of this class to explain all these kinds of things. Don't worry if you don't know what the heck I'm talking about. It isn't important. What is important is that there is a layer that sits right in the middle, right? It's called middleware in this kind of thing because it sits in the middle between this side and helps coordinate. Its goal is what's called choreography or orchestration. It's a coordination of these services and components. But middleware in this regard is a structural pattern. All right, this is an architecture, right? We have an architectural style here, a layered style. Here's a layer, here's a layer, here's a layer, here's a layer, and here's a layer, kind of thing. Okay, and this one sits square in the middle of that style, of that layered architecture is what I'm saying. And that's why it's called middleware. It's called middle, it's in the middle, but structurally. All right, that's the traditional view. That's what this diagram was that I cut and pasted here, is you would have different services for different applications or components that are running that talk over an API and then are serviced or coordinated by that middleware, right? This is the middle of this diagram. Okay, so it's middleware. All right, simple enough. Total structural viewpoint with respect to an architecture. Okay, and that's what this simple colored boxes mean from Lou's diagram in her distributed computing book. All right. Now, Express and Node has a different notion of middleware. All right. In web development, we refer to the sequences of calls made between accepting the HTTP request and generating a response as the request processing pipeline. In a traditional middleware view, the pipeline is a set of distributed process invocations. All right, think like a distributed call stack. What does that mean? That means, again, let me go back to here. Let me go back to my own diagram here. Again, I know I'm creating my mess again. But what I'm talking about is when you look at a call coming from a browser, all right, to through the internet, routed to some server, to some application server, to the middleware, to some end service. Maybe it is hitting a database and routes back again so you can generate this response. This entire sequence that touches on this node, this node, this node, this node, and this node, right? And by node, I mean computational processing node. There's a running program there somewhere. I've hit 1, 2, 3, 4, 5 of them. All right, and back, just in order to handle the response or handle the request and generate a response. All right, remember our 6 steps. So in the middleware view, you go through this pipeline, which is our 6 steps. In fact, let's do that as a review. What are our 6 steps? All right, step 1, handle request headers. Step 2, handle the params of the request. Step 3 is route request to a handler, assemble payload, set of the response, set response headers, and believe me, I have horrible handwriting and it looks worse than this digitizer. My 5th grade teacher accused me of writing with my feet, so I apologize for that. On top of that, I'm trying to write in an angle with this funky pen here. And then deliver or render the response as we've talked about. Right, so we've talked about this pattern before. This, we're still here on step 3 when we talk about this middleware. We're here with the routing of the response, into the back end to take care of all the magic that happens. And again, once we jump off into there, we're completely outside the realm of the web. The web is on this side of the line, right? This is all my web architecture over here. This stuff going this way. This is now going into my my business, my organization. I could, this site could be web. I could reuse this middleware for mobile apps that I'm running, for desktop apps, and all those kinds of things I talked about. So this is the website over here. Okay, and again, we're dealing with that handler being a delegation into that middleware area. Okay, so that step-by-step, that request processing pipeline that we go through, well, in the NodeExpress view, it doesn't take this object-oriented or kind of component-based. Think of in the simplest terms this component or service. Think of it as a coarse-grained object, meaning a big object. All right, basically, right? In object-oriented programming, we encapsulate behavior, state, and identity, and your application is viewed as a collection of communicating objects, and that communication is what you did in 3.15 for sequence diagrams and so forth. All right. that that object oriented is this whole interaction I'm drawing over in those diagrams is just their component. Again, think of components as just big objects. It's just taking these encapsulated behaviors and components and threading a request through there and generating a response. Again, functional programming wise, we talked about this at the beginning, encapsulate discrete computational tasks through functions, all right? So instead, the applications use a discretized or discrete set of tasks that comprise a workflow, all right? Combine that with what we just talked about with the MVC pattern, right? It gives us some idea of that control flow. So we also talked about the 6 parts of the MVC, if you remember that diagram, right? And dealing with those 6, we had 2 different ways of that pattern being realized. One on the Java side was having a servlet that delegates into the model, but in the Node world, we talked about a route, right? Define that entry point into the set of discrete tasks. Basically, we're routing the functions, right? When you looked at our call on Express, we had the verb, right? We had I'm writing in white space here, so I have to be delicate about this. Remember the app.some verb get post or all, and then dealing with the parameterizations of the request and the actual route, meaning remember we dealt with the route being the slash. Actually, these are on the other way, slash error, right? And we used this verb and this relative path to route to a discrete task or a function. All right, we had a callback here, right? That's where the callback came in. That's how we were routing. Okay. Now, so far we haven't really talked about how to structure those tasks. Meaning, as we get to the callback's just the entry point. That's routing, right? But we haven't talked about how to structure those tasks. And again, the request processing pipeline gives us some guidance for dealing with that. But we have to deal with it now in a functional programming paradigm. All right. So again, remember the template pattern, right? So I just had that up there, right? It's no different, as I've told you before, whether you're doing Node, Django, Ruby on Rails, Java, .NET, blah, 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 Perl, whatever. You've got to do these 6 steps, all right? So the key is in how you organize your work in order to do it, right? Your framework that you decide to use has to give you some sense of maintainability. So, you make sense of the work so you can be maintainable and extensible for that matter. You want to optimize use of shared resources, right? That gives you scalability. Shared resources, memory, disk space, bandwidth, CPU, these are all shared physical resources, and you have to share them across, as I said before, hundreds if not thousands of concurrent requests, so you have to optimize your use of that. You've got to work fast, right? We're about response time, okay? All that while remaining loosely coupled, in other words, being able to independently. Remember when we talked about the separation of concerns, right? Presentation, business logic, data access layer, right? We talked about these concerns in those tiers. Loosely coupled, again, allowed us to vary people and technologies to address the unique problems at each one of these layers, all right? So we have all these design goals, all these architectural goals of our system. So how does Node deal with that? How does Node organize? What's its organizing principle? Well, again, the organizing principle for Node is called middleware, but the middleware steps are not the same as the structural middleware we were talking about at the beginning of this talk in the traditional enterprise architecture. All right, in Express refers to the set of functions comprising the request processing pipeline. All right, after the route handling of the HTTP verb and the rendering steps. So now we're going back to, right? We're going to routing to this part down, okay, of a template or other subflow as middleware. So basically, you did your app.get with some relative path here, like /error or /whatever, and at that point, you're going to have a set of steps that you're going to invoke by using the .use method. Again, right, this was created by our Express constructor, traditionally called our app, and we're going to have app.use sit in the middle here. Before, we were just doing a callback and call and render, if you remember, when we used our template. But here, we're going to inject, if you will, All right, this is injection or the interceptor pattern. All right, if you want to look at a gang of four pattern, there's a gang of four pattern called the chain. I was going to write the COR, chain of responsibility. Okay, this is going to be a realization of this chain of responsibility pattern. I'll post a link to it out on the website. Okay, we're basically introducing steps in between the callback and the render call. All right, when you do that, then each step must invoke next, which means I've got to have when I hand off here, then I've got to put a next here for this one to this one. All right, and the ordering is depending on how you set it up, right? So who calls next and so forth in what order. All right, this is why we have multiple parameters on the callbacks inside of Express. All right, we have request and response. We have a next call. If you do not have a next callback or do not use next, the pipeline just stops. All right, that can be very bad if it's unintended, because eventually you've got to get to this rendering step, right? There are ways of dealing with errors that happen during this processing, and to go with a different rendering of your error at the end. That's It's not required, but the error handling callback is considered a good idea. So conceptually, though, the main thing I want you to take away conceptually is we had a traditional notion of middleware. That's this sloppy mess, or maybe it's a little bit easier to see on this one, that sits again structurally in the middle of this distributed architecture. But in middleware in NodeExpress is literally injecting injecting new calls in the middle, in the middle of the request processing pipeline. All right. This is still all running in the node process space. This is not calling a distributed service or whatnot. Now, it doesn't mean that the function that's represented here can't go talk to the mail server, or this one here can't go talk to a database. All right, they can, but this is a set of invocations that are in your call chain within the Node.js process, and it's called middleware, again, because it sits in the middle of that functional call chain. I'm making a good mess of this stuff today. Now, writing your own middleware is easy. These things are just functions, like I'm saying, introduced to the pipeline, right? So here's an example of the Express Listen MW1, but I'm not going to run this one, but just take a look at what it does. We get our app from our require of Express and invoke the constructor. There's our get, there's our route, and there's our callback. So this part we've done before, right? Response.send hello from Express. But now I'm putting in a next call. All right. The next call is going to, we've got a parameter here that we had set it up, right? So that next call is going to be invoked depending on which way we set up the invocation sequence. This is the one that appears next in the app.use. It appears right after this one. So that one's going to be next. First app.use call. It's going to call next, right? Boom, goes on. This one also takes parameter. It calls next, and then an app.use of console.log. If you notice, no next call here, right? This one isn't invoked right there, so I'm done. Okay. Simple as that. I mean, it's just writing your own middleware is as simple as writing the functions in order and expressing them in order, so they are injected into the call sequence like that. There's a lot of common middleware out there, so this chain of responsibility allows you to create some things that are pretty common, right? So for example, there's a JSON middleware built in to parse JSON encoded request payloads, particularly, this is when we're talking about our post. All right, this is becoming the emerging standard, way more popular. And when you implement REST APIs on the server side, using this kind of JSON middleware in order to parse the request payload is kind of the way to go. You can parse URL encoded information, meaning when you get stuff of the MIME type on the request payload of form URL encoded, then you can use this part. This is kind of the traditional payload. So the traditional way of dealing with a post payload was to MIME type the payload in this way. However, really the JSON middleware is becoming more popular. But again, it's up to you. It depends on how you designed your system, which one of these MIME types you're going to use, whether you're going to get URL encoded data or you're going to get JSON encoded data on the payload. But either way, you can inject whichever middleware is appropriate for the requests that you're handling. Body parser actually includes both JSON and URL encoded, so one require would include both of them. We talked about data compression. Maybe your request header said that you can handle, that the client says, oh, I can handle gzip data, and you want to generate gzip data. Well, you're going to go write the algorithm yourself, or can you just inject some middleware to say, oh, in this case, maybe this app.use here, maybe this is a gzip, so the last step I do before sending the response out and rendering it is to compress the content. Cookie parser and express session are both things that we'll cover as well, in particular in the next slides, because that sends you toward your next lab assignment. Keep in mind you can npm install a whole bunch of other ones as well. Okay, I'm going to stop this video and keep it short here because this was a conceptual overview, jumping into a little bit of Express. I want to talk about the cookie parser and the Express session in more detail, because cookie parser, we already talked about cookies already in one regard for personalization, user profile type use case. And I want to talk about session because we talked about this with respect to our stateful programming. So I want to spend a little bit more time on these two. I've got a few slides left on it, but there's also several code examples I want to jump over to, and that's what I'll do in the next video.